Indirect measurement. It's like similar figures. You can see here I drew some similar figures. Well, indirect measurement allows you to use the properties of similar triangles to find measurements that are difficult to measure directly. So you'll see in these examples, like the first one here, and there's two different ways you can find the missing measurement. Here we have a tower, 54 meters tall. It casts a shadow 18 meters long. A building that is 6 meters high will cast a shadow of blank. So you can see here, there's the picture. You have the tower with its shadow. You have the building with its shadow. And I drew a little line over here. When I drew this little line, this formed two right triangles. And they're similar because they're the same shape, just different sizes. So on this example, I found the missing measurement, the shadow of the building, by using my scale factor. So scale factor, I divided 6, and I knew that this 6, the new, is the one that has the missing measurement, and I wrote that down over here. To find the scale factor, divide the new by the old. The new image has the X. So if I labeled this is my new picture, this is my old. I need one pair of corresponding measurements for my scale factor, so I'm using those because they're both there. So I did 6 divided by 54, simplified and got 1/9. Then I took the 18 and I applied that scale factor of 1/9. It gave me 2. So 18 divided by 9 equals 2. So you can see here I drew 54 times 1/9, or multiplying by 1/9 is the same thing as dividing by 9, which that works. And then 18 times 1/9, or 18 divided by 9, you get the shadow of 2. All right, so that's one example using the scale factor. Now I have another example where the scale factor is not really going to work. I have a 9-foot flagpole cast a 6-foot shadow. How tall is the woman who casts a 4-foot shadow? So you can see the two over here. You've got the woman with her shadow. You've got the flagpole with its shadow, and I made them both into triangles. So you've got similar right triangles. Remember when we did similar figures, you can either go within the figures or between the figures. Either way, you're still going to get the same answer. So my steps: set up a proportion within figures or between figures as shown here. To solve a proportion, multiply the diagonals to create an equation. So multiply the diagonals and you'll get the equation. Then solve an equation. You would then, of course, divide by 6. Okay, so there's your other option, setting up a proportion, because similar figures, corresponding sides are proportional. If I continue on, now I had this other example, but this example didn't have a picture. It was just a word problem. But we have the Gateway Arch in St. Louis, Missouri is 630 feet tall. Suppose a 12-foot tall pole that is near the arch casts a 5-foot shadow. How long is the arch's shadow? So for my steps, it says draw a picture so you can have the visual. Notice all of these shadow problems have formed right triangles. So all you're going to do basically is draw one bigger, one smaller right triangle. I did mention to label it because that way when you're putting your information from the problem onto your picture, you know which one gets what information. So I just wrote, there's my arch. I didn't even draw any fancy arch. I just drew them as right triangles. But that's supposed to be my arch. That's supposed to be my flag. I put my information on here. This one I set up as a proportion. You can do scale factor if you can figure that out. But for myself, I prefer just going with the proportion. It's easier. Cross multiply 630 times 5, got 3,150. 12 times x, got 12x. Divide both sides by 12, and you've got the shadow of the arch is 262.5 feet. All right, one more example. Another word problem, and this one I worked out both ways. But let's see, little Billy is 4 feet tall and casts a shadow 12 feet long. He stands next to a sculpture that has a 36-foot long shadow. How tall is the sculpture? So, again, I just drew two right triangles, one bigger, one smaller. And in this case, I made Billy's triangle smaller because, he's smaller. So there's Billy with his values. There's the sculpture with that information. Here I did the proportion method. 4 over 12, x over 36. I've got 12 feet for the height of the sculpture. Or I did the scale factor method over here, still Billy and the sculpture. I noticed 12 to 36, that was times 3. So I did the same thing, 4 times 3, got 12, and there we go. So indirect measurement is when you can't directly measure, so you use similar right triangles, set up a proportion to find the missing value or scale factor. Don't forget, whenever it's a shadow question, when you're reading word problems and it doesn't give you a visual, but if you see it talking about a shadow, automatically think, okay, I'm going to draw two right triangles, one big, one small, put my information on it, and solve from there. Scale factor or proportion. Okay? Good luck.